Hello, how's everybody doing today? Today we will be investigating the experiment number 4, which is chemical equations and chemical reactions. The main objective of this experiment in Labflow is for you to be able to observe a chemical change and recognize the evidence of a chemical reaction. Then you will be given the chemical equation and will be asked to balance the chemical equation and recognize what kind of chemical reaction you have. So as we always do each week with each experiment, I will give you a quick overview of the experiment. Then we'll do a quick learning check with a few questions to make sure the concepts are there and you are ready to jump into the Labflow pre-lab quiz. And then the last part of this workshop is sharing the page of the report, and we'll go over step by step. And I want to make sure that everybody knows what to write in that report. And I expect everyone, usually that people that come to workshops, I expect you to get an A. So this is the intention of this workshop. For this report, you will be given 7 different reactions. For 2, are videos that you have to watch and then describe what do you see. But we'll go over that. And for the other 5, you will have to watch some pictures. So let's get started sharing the page of the experiment. Please let me know if you have questions. You can raise your hand, you can unmute yourself and ask a question or type a question. So please do. I like to make sure that everybody, that's my tradition, that comes to the workshops, understand the material completely. I will stay after we finish the recording, and if you have any question, this is your opportunity to get an A in everything corresponding with Labflow. Okay, so let's look at the page. This is when you click on the left, this is the page that describes the experiment. This week we have chemical reactions and equations. So the objectives we already went over is basically observations. That's why you are given a video. And we will observe together at the last part of the workshop when I explain how to complete the report. So these are skills that all scientists need to have. Actually, everybody needs to be able to observe and be able to describe what is happening. So this is this week's experiment about observing a chemical change and be able to explain it. And what do we use for chemical changes? We use chemical equations. So the objectives, we went through that. We'll identify the evidence of a chemical reaction, and then we'll balance the chemical equation, and we have to know what type of chemical reaction is that and predict the product. So we'll go over in this session all over this material. So what is a chemical change? Here they continue the page talking about chemical changes. We actually have seen in previous workshops physical changes and chemical changes. There was a whole experiment about that. So we saw, just to refresh, that a physical change basically changed the appearance of a substance, but not the identity. We insisted last week on identity, chemical identity. For example, we boil water. The vapor water is still water. We have a pot of water. We are boiling water to make pasta. Of the water boils, and we have the water as a vapor water, but it's still water. The formula of the water is still H2O, even though it looks different from the liquid water. In this experiment, it's all about chemical changes. So a chemical change or a reaction is different. In a chemical change, chemical substances form new substances with new properties. And here in this page, they give us an example. And it says an example is the oxidation of iron into rust. Where do they say that? A common example of chemical change is the oxidation of iron into rust. Now, if we are talking about that reaction, what are the reactants in that chemical equation? So we know it's a chemical equation, right? Here they don't write the chemical. So basically, the reactants are iron that reacts with the oxygen, don't have much room, to form what product? Iron 3 oxide. And this is actually the rust, right? We need to balance the equation. So we are going to say, okay. But that will come later. That will come later. So they give us an example here in the experiment of a chemical reaction. And they say the oxidation of iron into rust. Right, that is a chemical change. There is what happened. The reactants, iron and oxygen, combines and form a new substance, which is the rust. What is the rust? The iron oxide. Any questions so far? Okay. Then when we continue looking at the page of the experiment, here is something very important. It says, let me see if I can make it a little bigger. Okay. You can make it bigger on your own computer as well. I'm sure by now you know. So if we continue with chemical changes in this page, what do we see here? Signs. You will think about you are a scientist. You are observing a chemical change and you are thinking, is this a chemical reaction or it's not a chemical reaction? This is what we are learning now. So here in table 1, it gives us some signs of a chemical reaction that we will observe when we look at the videos in the report or the pictures. The first one, it says the common sign here. It says formation of a gas. So if you mix two substances and you see bubbles, then you know, a gas is formed. That's a sign of a chemical reaction. What else is a sign of a chemical reaction? When we have we mix two liquids, and here they're giving us examples, but we'll go over in the report. Another, it says sign, you mix, let's say, two clear solutions, like transparent. And what do you see? A solid forms, a precipitate forms. Why do we call it a precipitate? The same way the rain falls from the sky, we call it precipitate, right? The same way a solid forms in the beaker when we mixed the two solutions. So that's another sign of having a chemical reaction. Then what other things you have to pay attention? If you mix two things and you say, is this a chemical reaction or not? Well, if you see a change in color, then yes, a change in color is also a sign of a chemical reaction. Now let's look at the last one. It says heat lost or gained. This one, basically, the heat lost or gained, I want you to be careful with that one. It's listed here as a sign of a chemical reaction. Yes, it is. But what I don't want you to think is that always. Remember that heat lost or gained is a sign of a chemical reaction because it might happen. But what we cannot say that all chemical reactions are accompanied of heat lost. No, we cannot say that. It's not always. It's a sign of a chemical reaction. So take it with a little if you see a question, is not always. It's a sign that can be a chemical reaction. So remember that. And here it gives an example. It says reaction of hydrochloric acid and sodium hydroxide. So when we mix an acid and a base, sodium hydroxide is a base, what happens? It's a neutralization. An acid and a base always forms a salt and water. And that reaction is giving off heat. Yes, and that is a sign of a chemical reaction. So any questions so far? Okay, so let's continue then. Then when we look at the page of the experiment, we now have an idea. We look at chemical changes. Okay, what should we look in order to recognize if it's a chemical change? Well, yes, we need to look at all these things that we just mentioned in table 1. But then it's talking about chemical equations. What is a chemical equation? We use a chemical equation to represent a chemical reaction. I want you we now know, okay, we have a chemical reaction, but let's say, just to understand, for example, I would say a solid sodium, just as an example. I'll read it to you, or I'll tell you, I'll tell to my students, and I said, okay, I'll tell you a chemical reaction. The solid sodium reacts with liquid water to produce hydrogen gas and a compound that is sodium hydroxide. And I have to talk a lot. I have to say sodium solid reacts with liquid water. Chemist wants a simpler way of describing a chemical change. So they use chemical equations to represent a chemical reaction. So this is a simpler way. So everything that I read before to you, I can say, okay, a chemical, this is, I will give you the chemical equation. 2 pieces or 2 moles of sodium that reacts with 2 moles of water, and in parentheses, we write the state. The L represents liquid, the S solid, and instead of saying sodium solid reacts, which is the plus is react with liquid water to produce. To produce means is the arrow. Produce hydrogen gas. So I write hydrogen, and in parentheses, I write the state, hydrogen plus 2 moles of sodium hydroxide, that is aqueous. Aqueous means it's a solid dissolved in water. Aqueous means it's in water. The solvent is water. So this is what it is, chemical equations. It's the way we represent a chemical reaction. So we need to learn all this. So instead of reading all that long, we write this chemical equation, and it's much simpler. And this is a balanced chemical equation. We'll go over next. And here, what else we need to recognize in a chemical equation? What do we use? We use the plus here in case we have more than 2 reactants. So let's look at how do we call all the substances to the left of the arrow. This is the arrow. The arrow divides the products and the reactants. Sodium and water are the reactants, and hydrogen and sodium hydroxide are the products. So the arrow means the sodium, the reactants react with each other and produce the products. So we'll go over a little bit more about that, but I want to know that these are the reactants, and what is on the right side is the products. And the arrow separates both. And when do we use the plus sign? Do we always need to use the plus sign? No. Only we need to use the plus sign when we have more than one substance on either side. In this case, we have 2 reactants. We need a plus to separate them. And in the other one, we need a plus to separate them on the products. Any questions so far? Okay, so we'll move on with the experiment. Here, we are talking about the symbols that are used in the chemical equations. We went over that. The plus, you can read it later. The one we didn't go over is this little triangle. When you see on top of the arrow this little triangle, means that the reactants are heated in order to produce the products. We need heat for that reaction, and that triangle means that. And then in parentheses, if you see an S, indicates that the substance is solid, L is liquid, G is gas, and AQ is an aqueous substance, which means, as we just said, the solvent is water. It's a solid dissolved in water. Okay, if we keep on looking at the experiment, here it says balancing chemical equation. That is something you need to master for the whole, if you're going to do Chem 2, always. The balanced chemical equation is critical. So what does it mean? Now we know how to observe a chemical change, how to write a chemical equation. Is not enough. We need to balance the chemical equation. What does that mean? Balancing. You know the law of conservation of matter. What is that law? It says that matter or atoms are neither created nor destroyed in a chemical reaction. What does all those words mean? Basically simple, that the number and types of reactants must all the atoms on the reactant side must be equal in number and types of products atoms. Right? Let's look at the example they are giving us here. Let me zoom a little bit. So here they give us this example. Is this equation balanced? If somebody asks you, they give you this equation, and they ask you, is this equation balanced? What do you need to do? You look at the arrow, right? And you are going to make a table. You are going to say R for reactants, right? And then you are going to do another table for the products, let's say. And you are going to see reactants on the left side of the arrow. And you are going to look what kind of atoms do you have on the reactant side. So what do we have? We have hydrogen and we have oxygen. What do we have on the other side? Same thing. If you see a reaction that you don't have the same thing, you are in trouble. You created something from an atom that wasn't from the beginning. So we have the same type of atoms on both sides, on reactants, and we start counting. Let's see. Hydrogen. How many hydrogens do I have on reactant side? The way it's in here. Somebody can text me. On the reactant side, how many hydrogens, atoms do you see? I count here. I count 2. Yes. Somebody wants to say something? I can hear a noise.
Are you asking about the products?
Yes. I ask, how many hydrogen atoms are on the reactant side, which is left of the arrow? Here, I have 2 atoms, right? Hydrogen 2. I count 1, 2. And then I look at the same on the product side, which is here. And I count water has 2. And then I do the same for oxygen. Oxygen on the reactant side has 2. And then I look at the product side and I have only 1, right? I want to make sure everybody sees that. And then I look, hydrogen is balanced, means that the same number of hydrogen is in the reactant side and in the product side. Then I say, oh, good, the hydrogen is balanced. Then I go to the oxygen and I see it's not balanced because I have in water, I have only one. So what do I need to do? One important thing, very, 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 very important. When you balance a chemical equation, you only use coefficients. Only use coefficients in front of the in front of the substance to balance the atoms. You can never change the formula of any reactant or product. That's a bad. The formula, which means the way it's written here, the hydrogen, you cannot change it. You can only balance using coefficients, which means if I have to make two oxygens, my only option is to add a 2 here in front of the water. That is a coefficient. As soon as I do that, I need to correct everything. If I add a coefficient of 2, I will cross the 1 and I will write now I have 2 oxygens. And then how many hydrogens do I have? 2 times 2, I will have 4. Everybody follows me? And then if I have 4, I will look at the reactant side and I will say, oops, now I have to do something because the oxygen is balanced. I have 2 on here and I have 2 here. But what happens with the hydrogen? It's balanced. I have 4 on the product side and only 2 on the reactant side. So then I have to add in another coefficient. Any questions there? And once I add that coefficient, the reaction is balanced. Why? Because I have on the left side of the arrow, I have 4 hydrogens and 2 oxygens. And then on the right side of the arrow, I have the same 4 hydrogen and 2 oxygen. So I didn't create anything, and now I can say, yes, the equation is balanced. Is this clear, or you would like me to give you another example? Okay, let's look at
I have a question. Hello?
Yes, I can hear you.
So how come the oxygen on the product side didn't get a 2 added to it as well, or multiplied it? Or it did, right?
I think it got erased, right? Let me see.
Yeah, okay. Never mind.
No, it's okay. Let's look at your question. I want to make sure that it's clear. Let me see here. Okay, so your question is, this is the balanced equation, right? And what is your question? How come what didn't get a coefficient?
Oh, I think what confused me was the fact that there wasn't a 2, I guess, next to the oxygen, the product side, but
Okay, so
the
now we
2 is in front of the hydrogen.
Okay, let's look at why we don't add a 2. How do we count the number of oxygens? We have O2, right? This is the same as 2 atoms of oxygen. We count the number of atoms. So we count O2 as basically 2 atoms of oxygen, right? So we have here 2 atoms of oxygen. And now let's look on the other side. We have 2 molecules of water. This coefficient 2, which is the one that we added at the beginning, this big coefficient, affects the whole molecule, affects the whole molecule. The coefficient affects the hydrogen and affects the oxygen. That means in the formula of the water, if I will, this is the formula of the water, H2O. How many hydrogens I have? I have 2 hydrogens and I have 1 oxygen, right? So then the total, once I add the 2 in this black, how many hydrogens I will have? I have to multiply this coefficient by the 2 of the formula. So in the 2 molecules of water, I will have 4 atoms or 4 moles, whatever you want to think about it, of hydrogen, but only 2 of oxygen. Because the formula, if I don't add the coefficient 2, I will have 2 hydrogens and 1 oxygen. Because I added the coefficient 2, I want to know how many atoms total I have. And it's 2 of hydrogen, it will be 2 times 2, which is 4 hydrogen. And how many oxygens? Only the ones that are given by this coefficient, which is 2 oxygens. So I have on the water side, I have 2 oxygens and 4 hydrogens. And what do I have on this side? I have 4 hydrogens because it's 2 of the coefficients times 2 of the formula, and I have only 2 oxygens because I don't have a coefficient. Does it make sense?
Yes, thank you.
Yes, you're welcome. Any other question? This is so important, so please ask me, because otherwise it's gonna become more complicated. Then you will have stoichiometry, and if you don't know how to balance an equation, then you will be in more trouble. So this is why I'm here. How to balance is going to be important. So ask me. You can unmute and ask me if there are questions. Okay, so then we know. And let's say, just for the sake of, let's look at this. Okay, so let's say I have this equation. I'll give you this equation. Nitrogen plus oxygen gives me nitrogen monoxide. And I want to ask you, is this equation balanced? What do you think? You can text me or unmute. Tell me, is this equation balanced?
It's not balanced.
Not balanced. Correct. Exactly. Because on the reactant side, which is this one, I have 2 nitrogens and I have 2 oxygens. And what do I have here? Only 1 nitrogen and 1 oxygen. So the natural way of balancing, remember, is always with a big coefficient. So we need to write a 2 here. But please, I've seen it so many times. Don't change the formula. I've seen people doing like, they have this. Instead of adding, let's say, a 2 in front, they add a little 2 and a little 2 here. No, no, no. You cannot add subscripts. Why not? Because you are changing the formula. You are giving another product. If the formula of the water is H2O, you still form water. You cannot change the subscripts. So that is a concept that I always insist. Okay, so I guess with balancing, we are good. And now if we keep on looking at the experiment here, what do we see? It says types of chemical reactions. This is something that you probably went through in lecture, but we need this here. We need to recognize there is a classification of chemical reactions, and you are shown here some. They're very easy to recognize, but you need to learn how to recognize what type of chemical reaction you are having. So let's look at this. Okay, the first one, it says synthesis or combination. That is very easy, super easy. Some people call it combination, so memorize both. I call it synthesis. But here, it seems that more people use it combination, so I learn both. It's the same thing. What is a combination? It's very, very easy to recognize. You look at the product. You look at how many products you have after the arrow, how many substances you have. And the combination is when only one product is formed. So then you have a combination. See, you mix carbon and react with oxygen, and you apply heat, and the product is carbon dioxide, just one. That is combination. That's why it's easy to recognize. You look how many products are on the right of the arrow. One, okay, it's a synthesis. Then decomposition, the next one. Decomposition is kind of the opposite. Basically, how many substances you have at the beginning. Only one. One substance breaks down into simpler substances, and that is the composition. So you don't need a plus sign because you only have, on the reactant side, you only have one substance. Let's look at the next one. What other kinds you need to learn? Single replacement. This one, it's a little bit, I mean, not difficult, but you need to pay attention. What is the definition of single replacement? Let's look at that. It says one substance replaces another in a compound and creates a free element. So let's look at this reaction. Let me zoom because either I need, okay, now I can see better. So let's look at here. We have magnesium solid as a free. A magnesium here is like, it's an element in the periodic table. So it's not combined. It's as solid as the metal, magnesium, group 2. Going to react with hydrochloric acid. If you look at the formula of hydrochloric acid, is H combined with chlorine. And what is the magnesium doing in the product? Instead of It's replacing the hydrogen. Instead of being combined, instead of being, free as an element, it becomes combined. Is the magnesium is going to bond. Well, it's going to bond with 2 chlorines because it's group 2 and the oxidation number is 2. But the point of single replacement is that basically one substance, in this case magnesium, replaces another one, which is hydrogen, in our compound. So instead of the chlorine combines with the hydrogen in the product side, is combined with the magnesium. So you will observe that magnesium on one side is an element, and on the other side is combined. And you are also going to look at the hydrogen here. Let's look at the hydrogen. Hydrogen here is combined with the chlorine, but here, no, it's a free element. So then you are going to say it's a single replacement. Any questions there? Okay, so basically we have the single replacement. In general, you have an element, right, or an atom that reacts, in this case, with BC. In our case, it's 2 atoms that are bound together, hydrochloric acid. And you are going to form A, which is magnesium. Magnesium combines with C plus B. This is in general, you don't need to learn this. I'm just showing whatever is easier for you to remember what is a single replacement. These reactions are called redox reaction. I don't think you, at this point, you learn redox reactions, but redox reaction is when one or more elements change the oxidation number. One is oxidized and the other is reduced. But for now, you just need to recognize if this, they will ask you, is this a single replacement? And that's all you need to know, if it is a single replacement. And how are you to recognize that? Well, we already mentioned that one substance or one element replaces another in a compound and creates a free element. So basically, hydrogen is the free element. If you see a free element that wasn't there before, that can be a single replacement. Okay, and the second and the last is double replacement. Double replacement is much easier to see. This one is, but to me at least, is basically the elements switch places. So let's look at this reaction. Let's show this. They give you an example. I could give you another one. So we have, let's say, barium chloride that reacts with sodium sulfate, right? And this forms sodium chloride plus barium sulfate. And barium sulfate is solid. But let's not go much into depth in this. what I want to show you is that they change partners. We need to see barium is barium plus 2, right? It's a metal. And chlorine, you know, is group 7, is negative. What happened with the sodium? Sodium is positive, group 1, and the polyatomic ion sulfate is negative, is -2. So what happened in double replacement? Basically, the barium in here is bound to this chlorine, and they change partners. But because the only other option, positive attracts negative. So then, barium, if it's not going to stay with the chlorine, the only other option is sulfate, right? So it changed partners. And then these two are going to mix together. If the chlorine is not going to stay with the barium, the only other positive is the sodium. So basically, double replacement is not difficult. They switch, here the description, it says elements in two reactants compounds switch places. But you need to know switch this with the other. The positive has to look for the other negative, right? So this is double replacement. Any questions so far? Is it clear these double replacement reactions? Okay, and then the last kind of reaction is combustion. Combustion sounds easier to recognize. When are we having a combustion reaction? Usually, it's hydrocarbons that contain carbon and hydrogen that reacts with oxygen, and the products, most of the time, if you see CO2 and you see water, then obviously a reaction with oxygen, you will immediately recognize that is a combustion. So typically, a combustion is a reaction with oxygen, and most of the time, because you have hydrocarbons, it forms carbon dioxide and water. But I want to alert you that sometimes they might trick you. And you can have, as long as you have oxygen, think that might be a combustion. Sometimes the reactants have some other elements like oxygen or sulfur or nitrogen. And when you react those substances with nitrogen, then it forms, instead of CO2, if you have nitrogen and reacts with oxygen, is going to form NO2. So this is not very often, but I wanted to alert you in case you see those kind of reactions. Most of the time is hydrocarbons. Here you have a methane reacts with oxygen and the product is CO2 and water. This, if you see CO2 and water, you say, yes, combustion, no doubt. But also think about it. If you have, obviously to be a combustion, you have to have oxygen. If there is no oxygen on the reactant side, you will say no combustion. You need oxygen on the reactant side. But sometimes you will have a product that is NO2 or SO2, and that can be a combustion as well. Any questions so far up to reviewing the page of this experiment before we move? And then comes the procedure that we'll look at it when we share the page of the report. But this is just the basic of the procedure. Any questions before I move to the learning check? Okay, let's look at what we already saw. And it says here, determine whether each equation is balanced as written. So this is something, let's look at A. Somebody can unmute, take your time. We already went over on how to know if the equation is balanced or not balanced. So let's tell me, is A balanced? You can text me or send a message or unmute, because I'm not sure if that A is balanced or not. Somebody can help me.
It looks like it is balanced.
It is balanced. Thank you. Thank you so much. Yes. So how do we know? For the ones that did not answer, just to make sure. We need to recognize what kind of atoms we have in A. If we look at A, what kind of atoms we have? We have magnesium, we have hydrogen. I'm looking at here, magnesium, hydrogen. We have sulfur, and we have oxygen. And if I will look at the reactant side, I have one magnesium, I have two hydrogens, because the formula says H2SO4, I have one sulfur, and I have 4 oxygens. And on the product side, again, one magnesium, how many hydrogens? I count here 2, so I write a 2, and then one sulfur and 4. This is the way you will, one of the ways that you will learn or you will do to know, to see if it's balanced or not balanced. Okay, so then you look, oh, everything match, and then everybody correctly said that this equation is balanced. So we know that this is balanced. Very good. Let's look at B. Is B balanced? Let's do the same. You can do it on your side. Is this balanced?
No, it's not.
No, it's not. Yes. And what do I need to know to do in order to balance this equation?
You can put a 2 in front of wait, never mind.
Yes.
Yeah,
Yes.
put 2 behind H2O.
Very good. You are right. I can put a 2 there, and then I have 4 hydrogens on both sides. And then what else I need to do? Because
Put a
how
2 in
many
front of the O.
oxygen? Sorry, what did you say?
Put a 2 in front of the O on the
Yes.
product side.
On the reactant side.
Yes.
Right?
Sorry.
Yes. Awesome. Great. And now I have it balanced. What happened with the third one? Is it balanced?
No.
No, again, they give us work to do. So what do I need to do in order to balance this?
Put 2 behind aluminum.
Sorry, I put a 2 where?
Put a 4 behind aluminum.
A 4, correct. Exactly. Okay, so I think everybody, balancing is something you know and it's clear, which is very important. And now let's look at question number 2. What are the 4 common indicators that a chemical reaction has occurred? We talk about that when we look at the page of the experiment. What do you remember? We know we observe a chemical reaction and we ask ourselves, is this a chemical reaction or not? So we pay attention to what indicators or what is the evidence that there is a chemical reaction. So we talk a little bit about, let's see what you remember. It says 4. So what are we paying attention to?
If heat is gained or lost.
Right, the heat. But remember that I mentioned that it's not always. Take it with a piece of a grain of salt. Sometimes it's an indication of a reaction. What else? I need to see more. I couldn't hear, sorry.
If the products formed are way different from the reactants.
Yes, so we look for
New substances are formed.
right. And how do you know that a new substance is formed? So you can look for a color change. If you mix 2 things and you see that there is a color change, that is one indicator that it might be a chemical reaction. What else? How about bubbles?
Bubbles of a gas.
Bubbles. Bubbles is another indication because bubble means, oh, a gas is formed. And this is what we will do when we get to the report section of this workshop. You will have to pay attention if bubbles come or if a gas is formed. So we mentioned heat, color change, bubbles, and which is the next one? Remember when I talked to you at the beginning of the workshop about precipitation?
Yes.
The rain precipitates, it falls from the sky. Exactly. So we look at precipitate. So this is something for you to keep in mind. Okay, then any questions there? Okay, so we'll move to the next question. Predict the products and write the balanced equation of hydrochloric acid reacting with magnesium metal. So I need somebody to tell me what to write. Magnesium metal is easy, right? It's an element and it says methyl. So in parentheses, I want to write the state. But it says magnesium methyl reacts with hydrochloric acid. Reacts with, it's a plus. Hydrochloric acid. I write an AQ. It's a solution and I use water. And then what do I need to write here? What comes next?
It gives magnesium chloride.
Yes, but before that, what symbol do I need to write now?
An R.
Correct. Exactly. And you said that it gives me magnesium chloride and it's aqueous plus,
hydrogen gas.
very good, hydrogen gas. Okay, and now, is this equation balanced?
No.
No, so what do I need to do?
Put 2 behind the hydrochloric acid. Then
Yes,
another.
and that's it, right?
Let's see, yeah.
Okay, awesome. Any questions so far? So let's move to the next 4. What is the meaning, we mentioned that, of this little symbol, the
Change.
triangle?
Change.
Change is the arrow, right? But if I write an arrow and then a little
Heat change.
heat, is that what you said?
Yeah.
Okay, so this triangle means that heat is applied. Thank you. And then the last one is not very clear. I mean, what when it says what, I'm using some of the words that they use in Labflow. Some I don't like it that much, but it says what parts are present in every chemical equation. So if you have a chemical equation, what are you going to have? You are going to have at least one reactant. So one reactant at least. The minimum that you need to have in order to have a chemical equation. At least one reactant. Then you need at least one product. And then you are going to need an arrow. Is an arrow present in each chemical equation? The arrows are always present in a chemical equation. Yes. Every time you have a chemical equation, the arrow separates the reactant from the product. Are you always going to have in a chemical equation a plus sign? What do you think? Are you
Sometimes.
always? Say it again, please.
I say sometimes.
Sometimes, correct. Not always. You have to have either more than one reactant or more than one product. So that means that the plus is not necessarily present in an equation, but an arrow, yes. Okay, so any questions so far before we move to the report? We are going to go over the report, and I want to make sure that when the time comes, you are ready to complete all those reactions. Okay, so let's move to the report section. Okay, everybody can see this. Labflow kicked me out, so I had to log in again. So basically, this is the report that you will have to complete. Basically, the report has 7 different reactions, and because the objective of this experiment is for you to observe, you will observe 2 videos, and then we'll go over and try to do the report. So let's observe, pay attention. I hope everybody can see. Everybody can see the screen. Okay, let's look at this. What is happening here? Let's look at it one more time. Pay attention of what you are looking at. You have a piece of magnesium and you are burning magnesium. What do you see? Because the objective of this is to observe and be able to write what your observations. So last time, before we, this is a piece of magnesium metal and they are burning. You will see that when you do your report. Okay, so now we are going to stop this and okay, let's share this now. We observed the reaction of magnesium and oxygen. And basically, you will do 7 different reactions, as I just said. And you will have to write here. They will ask you to write. So what is the appearance of the magnesium? You start with a shiny silver metal, let's say. So you have to describe, and then you will have to describe the evidence of a chemical reaction. When we say evidence of a chemical reaction, you will have to write some of the evidence that we've been looking at, that we mentioned before. If there are bubbles, if there is a precipitate, if there is a change in color. And then they are very generous here because they give us the equation. They give us the equation. They said magnesium reacts with oxygen when you burn it to form magnesium oxide. And they only ask you to balance their equation in the report. But you need to write the evidence. This is in a way, now that you went through all my explanation, it should be very simple and you don't have to write much. Pay attention not to miss anything. So you are going to describe what you saw, and then in this case, the metal disappears and is converted into a powder. But this is not actually enough. The description here. What is it that you saw actually? Write it down. What is it that impressed you that you are going to say this is a chemical reaction? You saw a lot of heat, a lot of light also. And the reason is because when the magnesium oxide forms, is basically this reaction produces a lot of heat. And they mention it at some point, don't look at that light, because when the magnesium becomes very hot, it's going to emit light, and the visible light is okay, but it's going to emit also UV light that is not good for our eyes. Okay, so I think I'm going out of the point here a little bit, but what you need to know, let me see if I can share a better something. Let me see here. This one, no, okay. The evidence that is written here, I don't want to give you all the answers, but I want you to know what to write. And they give you the chemical equation, so you only need to balance. And actually, I forgot. What kind of reaction was that one? Magnesium reacted with oxygen to form magnesium oxide.
Combustion.
It is a type of combustion. It is, but it's actually, we call combustion when there is when we have hydrocarbons, and sometimes hydrocarbons that have some nitrogen, but in this case, when an oxide is formed, look at the number of products. We have only one product. So what kind of reaction is that?
Combination.
Combination, correct. So reserve the combustion. I would do that for just hydrocarbons reacting with oxygen, and sometimes when the hydrocarbons have some nitrogen or some sulfur, as I said before, it's called also combustion. But in this case, when a metal reacts with oxygen, even though oxygen is a reactant, it's a kind of combustion, but it's more used, they classify this reaction as a combination. Okay, any questions so far for related to the first experiment? So then you are going to have the second experiment, which is the reaction of zinc and copper. Let's look at these two images. Let me see if I can make it smaller. You will have that in your report. So let's look at the first one. What do you see in the first drawing? This is all about observations.
It's a blue solution.
Exactly, a blue solution, which is the solution of copper to sulfate. And what else you see? A gray metal here, this metal, and this metal is the zinc. And this solution is the copper sulfate. So we start with a solution of copper sulfate, and we put the metal zinc inside. And then they will show you in the second image, they will show you this. What is the difference? What is the difference between the two? So you will need to describe. Initially, you are going to say, yeah, I have a blue clear solution and I have a gray metal. And then they will say, the second picture is about 30 minutes later. What do you see?
Colorless solution.
Yes, exactly. The blue color fades. It's correct. And then what else do you see? That the metal is covered by a black or dark solid. So basically, what do we see here on the bottom? We see a precipitate, right? This is a precipitate. So when they will ask you what is the evidence of a chemical reaction, precipitate is one of those. Can be bubbles, can be precipitate, and also a color change because the solution fades. And they are kind enough to give us the reaction. Basically, this reaction, you don't have to think about it. They are saying the zinc reacts with the copper sulfate to give you the precipitate of copper plus zinc sulfate. And this is the dark that you see. And they will ask you to balance the equation and ask you, what kind of reaction is this one in your report? So now it's a what?
A single replacement.
Perfect. Yes, this is a single replacement reaction. Exactly. Very good. And then we'll move to the third one. And they give you this image here in your report. What do you see?
There's a colorless solution. Then there's a silver metal in it.
Right. So here, this is the reaction of magnesium. They will tell you magnesium reacts with hydrochloric acid. And basically, they will give you the reaction. And it forms hydrogen gas plus magnesium chloride. So there is a chemical reaction here, but they will ask you to observe as a scientist and say, okay, what happened in the first picture? You have a piece of metal here inside the hydrochloric acid. And after 30 minutes, so before, you can only say, okay, what happened actually after 30 minutes?
There's bubbles.
There's bubbles, an indication that a gas formed.
Yes.
And you see that the solution is a little, is not clear anymore. You can also say that here it seems that a little piece of metal, the metal here is a little smaller. Some disappear. So you can describe everything that you observe, but the indication of a chemical reaction is, I think, would be the bubbles. And then in your report, they will ask you, okay, balance this equation, and they will ask you what kind of reaction is this one? Which kind of, what type of reaction is this one? Can everybody tell me?
Yeah, which one I should? Is that a falling salt?
We have magnesium reacted with hydrochloric acid. How do you recognize what type? Do you see one substance?
Single
Replacement, exactly. Replaces another one in the compound here and creates a free element, which is hydrogen in this case. Correct. So we have this reaction is a single replacement. Very good. Any questions so far before we move to the next image? We have a few more images. Okay. Look at this image. This is the reaction of potassium iodide and lead nitrate. And they give us actually the reaction. It forms, and they tell us that this is aqueous and this is aqueous. and this is aqueous as well. And it forms a solid precipitate as potassium nitrate, which is aqueous. So basically, I am mixing here. They will explain here in the, but basically, you are mixing two solutions. This is the product, but you are mixing two solutions. Let me change the color. This solution and this solution are colorless solution. When you mix those, what is the evidence of a chemical reaction?
Precipitate.
Precipitate, correct. And what color is the precipitate?
Yellow.
Yellow. A yellow precipitate forms. And they ask you to balance the equation, and then they ask you, what type of equation is this one?
That's a double replacement.
Very good. Everybody sees that this is a double replacement. Basically, potassium here, instead of being happy bonded with iodine, basically the potassium went to the nitrate, and they changed partners. And the iodine bond with the lead. So it's a double replacement. Any questions there? Okay, so let's go to the next one. Let's see, it's super big, this image. Can you see this image? This is the next reaction that you are going to see in the report. They give you this reaction. So what is that you are mixing here? In this reaction, you are mixing an aqueous solution of iron chloride, which is clear yellow, is this one here, iron chloride. So you are mixing a clear yellow solution with a colorless solution. This solution here, before the precipitate forms or the color change forms, is clear. So what they will give you the reaction. What is the evidence of a chemical reaction here? We are not going to have a precipitate. We don't have a solid, because when you look at the reaction, in order to be a precipitate, you can write this in many ways, but because Labflow writes it this way, I'll go with what they do. So they write this complex in this way, and they say that the product is aqueous, which is this plus potassium chloride. Okay. So basically, if they say this is aqueous and you look at the products and both are aqueous, you cannot say precipitate as an evidence of reaction. You have an aqueous solution, so you will say a color changed to brown reddish. And that is the evidence of the reaction. Any questions so far? Let's go to the last images. We have two images. There is a movie that you are going to watch. If you want, we can do the last two. Now, I know the time is how are you with time? We need to go through two more reactions. I can leave you do the, if you want, the video, and let's look at the last reaction. Reaction of hydrogen peroxide. So they give you this image, and they give you the reaction. And they say, the image below shows the result of adding a catalyst, hydrogen peroxide solution. And they give you basically the reaction. They are saying that hydrogen peroxide decomposed to water and oxygen. And basically, what is the evidence? Oxygen is gas. So you look at the reaction and you see bubbles in the image. So what is the evidence of the reaction? Bubbles formed and the formation of a gas, which is oxygen. And then you will need to balance the equation and say what kind of reaction is this one. Which one is this one? What kind of reaction is this one?
That's a decomposition.
Decomposition, very good, because we have only one compound here. And I guess you have one movie to watch it's very, very simple. You are going to see in the movie, the reaction that we didn't do, a reaction of basically sodium hydrogen carbonate reacting with hydrochloric acid. And you are going to see bubbles because they give you the reaction, it forms CO2, and they will ask you what kind of reaction is that, and that will be easy to respond. So I will stop. I want to thank everybody for being here. I will stop the recording, but I will stay because I know there are some questions. So thank you, everybody.